Sure. My name is Steve Milner, and this is...
Hi, I'm Jeff Ligon. Nice to meet you.
We both are part of the Red Hat CoreOS team at different levels here. But we're going to be going over what is Red Hat CoreOS. So before we get started, I have a couple questions for the audience. So first off, how many people here have used Container Linux, aka formerly CoreOS? Okay, we got a handful of folks. How about how many people here have used Atomic Host, whether that's Fedora, RHEL, CentOS? Okay, slightly more people. Cool, cool. Now, how many people here have installed OpenShift? Okay, so not used, but actually installed it. All right. How about Tectonic? How many people here have actually played around with and/or set up a Tectonic cluster? Okay, we got one person here. Okay. Well, so these questions are just a gauge to see how deep we should be going into some of these topics, but
Not yet.
we'll move. Yeah, there we go. We'll move on forward here. So, what we expect you to learn from this talk: when and why did container-focused distributions start appearing? A history of Container Linux plus Atomic. So, the acquisition, what kind of happened after that? The use cases or use case of Red Hat CoreOS, depending on how you look at it, and foundations for the following talks that are going to happen in this room. So we have them listed up here. Of course, you can see it on the schedule, but there's going to be a couple other ones that come off directly after this talk that are going to be in the same room around Red Hat CoreOS / immutable host related items. So we're hoping to set up a foundation so that you could follow those talks as well.
And the plan is for this one to be very high level, hand wavy, and not too nitty gritty. And then later on, other speakers are going to be going into deep detail about things like ignition and other technologies.
Exactly. So this is kind of where it started here. So before there was a CoreOS, most people were utilizing containers, and at that time that was pretty much Docker on general purpose operating systems. So we're talking about RHEL, we're talking about Fedora, we're talking about other distributions. And this makes total sense because that's what we had at the time. However, once CoreOS popped up, it became really, really obvious that having this larger infrastructure to essentially run your applications on a host that you really don't want to be modifying kind of makes sense to have this. So if you think about it from the point of view of travel, you have a lot of options. So like here in Brno, you can get to and from the conference a lot of different ways. You can take public transportation, you can get in a car, you could even ride a bike. All those things make a lot of sense. But you have other options as well. You could use a seaplane. You could drive a tank. These things are options, right? But they kind of don't make sense for those use cases, or at least they don't make as much sense for those use cases. And that's kind of what we have here. We have container-focused operating systems, the first being here of CoreOS. So I believe this was actually the very first release of CoreOS. Version is 94.0.0. Does anyone know why it was 94.0.0 and not 1.0 or 0.01 or anything like that? Any ideas? Other than Andrew, but I will call on Andrew if nobody else knows. Go ahead, Andrew. Why is that the case?
Container Linux is versioned as the number of days since the start of CoreOS the company.
That is correct.
Day 94.
Day 94, this was the first release, right? And it really, it took off pretty quickly. Once people started playing around with the idea of having this immutable host to run their containers on it, have very light management that they actually had to do, it was simple. It really blew up. It just went everywhere. So we're going to talk a little bit about the projects and the tooling that went around with CoreOS. So not necessarily directly in CoreOS, but either directly in or around those things. So the first one I think pretty much everyone is going to be familiar with, and that's etcd. Distributed key value pair, used a lot with Kubernetes, OpenShift, and a heck of a lot of other stuff. I won't jump too far into that, but Ignition. How many people here are familiar with Ignition? All right, cool. It's actually extremely foundational to both Container Linux and Red Hat CoreOS. There's going to be a talk on this a little bit later, but basically think of Cloud Init, but way earlier in the process. So you can actually provision disks and do all that kind of good stuff that you can't do post-installation with Ignition. And as we go through a update flow, you're going to see where this shows up in terms of updating Red Hat CoreOS and how it could be used for other processes as well. Mantle was also a big one, and this is one that we use in Red Hat CoreOS. It's kind of a collect-all of tools that are used to either build items, to test operating systems, or to push images around. So I think there's about 7 or 8 projects underneath the Mantle GitHub repository. They share each other's code. That's why they're all in kind of one location. Cola is a big one. Or is a big one. Cola is kind of the unit testing of the operating system. Or is a big one, moving these images around into different clouds and that kind of good stuff. Fleet. Anyone here use Fleet? Have used Fleet, I should say. No, OK. So Fleet was an early one with CoreOS, and this was kind of scheduling systemd units into a cluster so that you could run things. So it wasn't just like Ansible running something and getting systemd units on all your machines and running something, but you could actually schedule where things were running within that cluster. And it also acted as a distributed system for systemd itself. It is not really used much any longer. Part of that was having a stampeding herd type issue where if you had a whole lot of machines, they'd all be checking into etcd. And even though etcd is really resilient, if you have thousands and thousands of machines just hammering and watching and holding on, even etcd can't always keep up with that. So there was moving away from that. Torx is actually a really interesting one as well. If you think about OpenShift and Kubernetes, they are tied very strongly to the container runtime. Now, if your focus is on that, right, running Kubernetes or you're running OpenShift, you need a very specific version of, at this point in time, it was Docker, but whatever that container runtime is. Users who wanted to run container workloads outside of, say, OpenShift or Kubernetes generally wanted a different version of Docker, the latest supported version from either RHEL or from maybe the company itself or some other location, while Kubernetes tended to hold back on older versions of Docker. Now, Torx was a way within CoreOS and Container Linux to be able to essentially say, OK, we're going to ship with a version of Docker so that our customers will be happy. But if they install Tectonic, we can turn it over to an older version, which can be used by Tectonic so that the cluster works at that level. So Docker was not the only example. There were some other things that you could also move around for that, but that was kind of the biggest thing. And when we get into the Atomic side, we're going to see that the Atomic team actually figured out a similar process, but using a different tool set. Rocket, another container runtime. Toolbox, since most of these types of operating systems don't come with a lot of developer tools on purpose, or I'm sorry, not developer tools, but debugging tools on purpose to keep the size small. Toolbox is a container system to pull down debug tools so that you can run them on these systems if that becomes necessary. And the last two here that we're going to talk about, Flannel, just essentially network fabric for containers, and operators, which came later, which there's actually been a decent amount of talks here in DevConf on the operators, but the high level of operators is essentially extending Kubernetes or OpenShift, providing more functionality through the Kubernetes API, and then being able to action on those items within the cluster itself. So obviously there's a ton more, but those are kind of the more relevant items for that.
So then when CoreOS was releasing this, there was plenty of concern that this new way of doing immutable infrastructure was going to be so exciting and so interesting and everybody would want to do it that Red Hat really needed some kind of response. And the direct response that came out of Red Hat was Colin Walter's OS tree project that created Atomic Host. And as Atomic Host got a little bit more mature, we added more and more items to the umbrella organization of Project Atomic, and that just became everything that's container related should kind of be there, right? And this was also kind of at the same time as OpenShift was really getting really big, and there were container related things, but it wasn't really a good idea to put OpenShift under the Atomic umbrella, and so they kind of merged and became together Atomic OpenShift, which is a little bit closer to where we are today. So for Atomic Host, we've got 3 different versions of it. We've got the Fedora Atomic Host that we spin out upgrades every 2 weeks. We've got RHEL Atomic Host that has a faster lifecycle than RHEL itself, and it comes out every 6 weeks. And we've got Cent Atomic Host as well that is basically a rebuild of the RHEL Atomic Host stuff that we're already doing, right? And all three of those all share OS tree as their base foundational immutable infrastructure solution, where it will lock down the packages that are there and only allow you to install new ones with RPM OS tree, right? The big thing about OS tree is, next slide, transactional updates, right? If anybody went to Colin's talk yesterday, his dream of an update is as the host is updating, somebody can pull the power and it's still going to be okay. You will still have a host that you can boot into just by rolling back to the previous installed operating system, right? And we like to throw around the metaphor of Git for the operating system, where you have snapshots of the state of the entire OS as an image. And you can move between those snapshots and move to different sets of packages and things that are there. And on top of that, you can also add new things to make a dirty tree, right? You can add in a couple different versions of Docker if you'd rather run with a very, very recent version of Docker somehow, if you can get the repo pointing at it. And at any point, you can always roll back to a previous version that you know works, right?
So real quick, I wanted to go back to this and note how fast the response was. So this was Tuesday, 15th, April 24th. So I believe that was roughly 7 months after the first CoreOS release. This was announced, and we were already trying to compete with our current coworkers.
They were that big of a threat.
Yes. So Project Atomic did a lot of the same type of stuff. So we just talked quickly about OS tree and RPM OS tree, but system containers was very similar to Torx, in that the attempt there was to be able to switch to different runtimes or use a different kubelet or things like that. But instead of doing it through moving files around or pointing something to something, a link somewhere else, it was through using runc. This is before Podman, using runc and not using a direct runtime other than runc itself.
And the point to really hit there is that anytime you're using immutable infrastructure, it's not that you want everything locked down all the time. You want controlled mutability, right? You want to be able to change a couple small things, and it's a matter of what you want to allow people to change and not really turn the entire thing into back to vanilla RHEL where you've got everything installed that you could possibly use.
Exactly.
But there are cases where sometimes you are going to need one more thing for one more customer.
Sure.
Right?
So other things we had there, the Atomic CLI, which sort of just sat in front of a lot of other tools, and this was meant to be a management type tool. So an administrator would log into these nodes and run Atomic CLI to do something like pull down installations of pods or things like that. Be able to pull images, be able to install system containers, be able to do an update of the system, et cetera, et cetera, et cetera. Builda, I think people are pretty familiar with that, building OCI containers, Scopio, moving them around. Cryo, which is actually an implementation of the CRI, or the Container Runtime Interface for Kubernetes. And Cockpit, which was actually still is a really awesome UI and integration into management of systems. And again, lots and lots of other tools that our teams owned and still own, but we won't jump into too much of that.
So last year, like 2 days after DevConf, we flew home and we started getting calls saying, "Hey, did you hear the news? Because we bought CoreOS."
Yeah, there was a guy we saw on Twitter that cut off his beard. It was pretty interesting.
Yeah.
But after this happened, so did this. OpenShift 4.0 development started going down, and what we knew is that for the Atomic team and for the Container Linux team, we were coming together and we were going to be helping significantly on OpenShift from that point forward. So no longer was there going to be an operating system that somebody's going to install OpenShift on, but there's this combined thing. So actually, before we go forward anymore, the steps to install OpenShift previously or currently is you have hardware or a cloud, right? You install your operating system, whatever that might be. We'll use RHEL as the example. So you install RHEL, get your keys there, you're all ready to go, everything's great. You get OpenShift. You install OpenShift using, in this case, an Ansible installer. So yeah, great, you have OpenShift now on top of RHEL. And your next move is Well, day 2, I need to provide some updates. I need to get this machine updated because there's some CVE or there's some update that I'm required to have. Well, great. You update the operating system, you verify that works. You update OpenShift, you verify that works. Oh, something's not matching now. Or maybe it is and everything is great. But there's a lot more management overhead for that. A big jump here was that we were going to start combining these things together. So no longer would it be a multi-level, you have to manage everything at multiple levels, but instead it was, you got your cloud or your hardware? Great. Install OpenShift? Okay, great. Now manage OpenShift. It's all one thing now. There's no more of these multiple layers that you're going to have to deal with. Everything is managed through the cluster, not at every single level you must manage those things individually.
And that really came from the outstanding work that the CoreOS folks had done with Tectonic of making sure that the version of Tectonic really defined what version of Container Linux was running underneath, right? They were really married and they were really in sync because the developers would just go downstairs and say, hey, I need this from you guys.
So as the team started jumping together, we had to come up with a philosophy. So a lot of the philosophies that we already had just matched right off the bat. So the first 3 there, the minimal, the immutable, and the effortless management. So minimal in this case are things like dynamic languages are not desired to be on the image, nor is extra development tools or extra debugging tools or anything else that's not going to be used on a at least monthly basis. It's just not needed. And all it does, at least for the updating, installation, and management, is cause more download time, more packages that need to be revved, more things to track, all that kind of stuff. So just like Container Linux, just like Atomic Host, we wanted to keep those things as small as we possibly could. Again, a big thing too is the simplified install. So with Red Hat products, we tend to have Anaconda, which is actually really, really awesome. However, when we pulled CoreOS and Atomic together, we realized we have a very, very specific use case for installation. And that use case is get it on disk, don't touch it. And giving people a lot of options to mess with the installation was counterproductive for us, at least at this time. And so we actually ported the Container Linux install, is that what it was, or CL install? Yeah, CL install, into CoreOS install, which is a shell script that essentially DDs the image onto the drive. The biggest portion of this installation script is a GPG key. Pretty much everything else is 5, maybe 10 lines of code to get this onto the disk. Now, that might sound a little weird, right? Okay, you've got it on the disk, but the disk might be significantly larger than what you just DD'd down. So what are you going to do? Well, that's what Ignition is there for. So Ignition, once it starts doing its first boot, it will start provisioning those disks, growing thing, like basically takes over from that point. If anything needs to be laid down, if anything needs to be modified, that is where it happens. And you're going to see a little bit later how that ties back into OpenShift as well. The immutable thing, there's, as Jeff said and Colin said yesterday, it's more about controlled immutability. So you can still drop files down, not everywhere, but in certain locations. You can still change configuration files. You can still update SSH keys. But if you're trying to mess with system-related items, it's not going to work. It's not going to allow it. Unless you take extreme measures to do so, of course. At which point, it's kind of sort of not Red Hat CoreOS any longer. And the effortless management. So for those who have used or not used Container Linux in the past, it's kind of like a continuous rolling release that just keeps on going. And you can opt in / opt out of these updates being applied to your machines. So you're not sitting around going, oh, well, I just read the release notes of XYZ and it had this issue and I need to go ahead and install these updates. But instead, it's either automatically applying or you're sitting there going, okay, I got an email or I saw this thing happened in terms of a CVE was posted online or whatever. So I'll go ahead and say, yeah, go ahead and make this a little update. On the Atomic Host side, we ended up adding in a timed update mechanism, which acted similarly, but not exactly the same. So you could also opt in and consistently get new OS tree updates at that point. And the last two here, opinionated actually came from Container Linux. So Atomic Host was not nearly as opinionated as we should have been. We started off pretty opinionated, but over time kind of allowed it to become a bigger set of things. So we were focused, and then over time it was, well, okay, yeah, for that use case, we'll go ahead and add those libraries. Oh, yeah, all right, for that other use case, we'll go ahead and add that service. Oh, all right. And so instead of being focused on either running the cluster or container workloads directly, it started becoming a container optimized operating system that does a lot of other things, but maybe you shouldn't, but you probably will operating system, as opposed to being very, very opinionated on it. So when our friends from CoreOS came over, they nicely called us out on it, and we made sure to stick with that from that point forward. So everything that we choose is for a very specific purpose, and we're not choosing multiple items. So when you see the runtime, we've got one. When you see the cluster, we have one set of cluster components. When you see any of those items, it's one for one specific reason. And then the last thing here is focusing on the cluster. So we embed the OpenShift packages, and as I said before, we're pushing management to the cluster. But it's not just that, we're also versioning with the cluster. So both Tectonic and Atomic had issues when trying to work, both Container Linux and Atomic had issues when trying to work with the clusters above. And part of this was they were their own operating systems with their own use cases, with the schedulers on top with their own use cases. And so the runtimes didn't always match, the libraries didn't always match. Basically, there was a lot of hoops that would have to be jumped through to get these things to work. And essentially by versioning the container runtime, the operating system, and the container scheduler all together, we can continuously ensure that these always work lockstep and they all feel like one entity, not multiple entities that are separated.
So a lot of the things that we had to choose from were things that came from both Container Linux as well as Atomic Host, right? So one of the choices that we were forced to go down was, are we going to stick with the roller mechanism that CoreOS did with the initially Chromium work and then eventually became a fork of that? Or are we going to stick with OS tree that was a little bit more native to Atomic Host? And luckily, we both came to the decision fairly early on that OS tree was a little bit easier to use and we had a little bit more control over what was going on with OS tree, and we really liked the ability to have multiple different images on the disk, not just the two. There had been cases where CoreOS had updated and then updated the other partition, and then at that point you kind of run out of backup plans if both of them don't work, so you wind up with the brick machine. And with OS tree, you can lay down as many updates as you need, and as long as you've got the previous one that worked, you can continue adding more on until one new one works, right? So a little bit more flexibility and a little bit more rescuability, right? The toolbox we thought was amazing and had some really cool tools, and so we really wanted to move that over in. And we made some other decisions about the stack where we're going with Cryo for reasons that I can't really get into, but I'm sure other talks have covered why we love Cryo. Ignition was kind of the way that Tectonic installed, and since OpenShift and Tectonic were working very close together, very early on the architect said, well, we're going to go with the Tectonic installer route, and therefore Ignition had better be on whatever host you choose, right? So that was kind of laid down, and we've learned to love it, and it's come a long way, and it's super, super useful. Build is what we use for building container images, but we don't actually have the builder package on the host. It's actually up in a library inside of the OpenShift packages, right? And let's see, Scopio, I believe, also is included, vendored in Podman, so it's there, but it exists as Podman, right?
So we picked up a couple other things here. So Podman, which there's been a lot of talks around that. Obviously the kubelet and other tools from OpenShift. CoreOS Assembler, which is what actually creates Red Hat CoreOS, as well as its image payload, which we'll talk briefly about later. We don't include the machine config daemon, but it does run on, and it's specifically made for Red Hat CoreOS, which is something that senses changes, and we're going to go through a flow of that shortly, and is able to intelligently create updates as well as changes to configuration files and all that kind of good stuff. And then pivot, which is sort of a layer in between a lot of these other items, which we'll also see in that flow. So we can talk very briefly here, we'll go through these pretty quickly, of differences here. So container Linux, right, designed for general container workloads, just like atomic host. RHEL, literally all the things. You can do whatever you want, but right, it's on you to make sure that those things are updated there, set up the way you want them to work. And Red Hat CoreOS, which is designed to power a container scheduler. In this case, it's OpenShift specifically. But this is kind of what it boils down to as being part of OpenShift now. So we are really the abstraction layer between the hardware and above. So we are a component of OpenShift, no different than the kubelet is a component of OpenShift, no different than the logging layer is a component of OpenShift. It is all together, it is all included. Obviously, hardware cloud is not, but everything from Red Hat CoreOS up is all one unit when it comes down. So we have some other items here. Container Linux provides multiple runtimes, RHEL, whatever you install is there. Red Hat CoreOS is specifically one in its cryo, which is an implementation of the CRI, like I said before. So it is specifically meant for Kubernetes / OpenShift, not for other container runtimes or workloads, I should say.
So some of the other choices for operating systems, a lot of people really love the Gen 2 base kernel and the content that came in Container Linux. We are a RHEL shop, so we ship RHEL content, right? And so Red Hat CoreOS is going to have the RHEL kernel in it. It's going to have RHEL RPMs. It's going to have OpenShift RPMs, and it's going to be managed if you need more packages by RPM OS3. But generally, nobody gets to choose that except for OpenShift. Yes.
We can have hardware support to run on bare metal instead of fully virtual.
That is one of the things that we are working on. Yes. Oh, sorry. Are we going to have support for bare metal for Red Hat CoreOS? And yes, that is one of the things that we are working on. That is one of our items for us to deliver, yes. So this is basically the comparison between the three operating systems, and we've got a couple more to go through.
Yep. So this is an interesting one, in my opinion. So Container Linux used Omaha for its update mechanism. Is anyone here familiar with Omaha, or the Omaha protocol? Of course, yes. All right, so it is actually the same thing that is used from Google for updating Windows components in some cases, as well as it was used, I don't think it still is used, or at least it's not used as much as it was with Chrome OS for delivering the updates to Chrome OS box. So essentially it was reused along with Core Update to keep Container Linux updated. We know how RHEL is updated, right? It's the tried and true RHEL repositories and or satellite, etc. But with Red Hat CoreOS, it's something called the MCO and the MCD. MCO is Machine Config Operator, which again, it's that operator word that you've probably heard a heck of a lot while you've been here. It lives up in the cluster, and it's sort of in charge of passing off items to the MCD or the Machine Config daemon, which will then consume that information, make an intelligent decision if it's possible to actually action on this information. And if it is, it's going to update the system, update files, update configuration, and restart. So you have a brand new system coming, well, not brand new, I should say, an updated system coming back in to the cluster. Or to say, no, I can't do that, respond back up to the cluster and say, you need to destroy me and reprovision me because it is not possible for what you're asking.
So security. The security model for Red Hat CoreOS comes from RHEL, right? That's the main reason we're using the RHEL kernel and RHEL content is we want to make sure that all the features that we support in RHEL are going to be available in Red Hat CoreOS. We want to make sure SE Linux is in enforcing mode. Container Linux has SE Linux on it, but it's impermissive, so it might as well not. And we want to make sure that any CVE updates that we're getting from RHEL can be easily applied, and having to do all that work twice for every CVE that we find just seems like madness. So that is another reason for the content choice that we went with. Mm-hmm. Another reason to keep the package set small, one of the reasons that we want to get things off the host as much as we possibly can, is to make sure that we've got a minimal footprint for places where somebody can come in and try and find one of those CVs. We want to make sure that the cluster is in control, OpenShift is in control of exactly what goes onto the host, right? And allowing them to have one big button that appears in the OpenShift console that says, you are able to update. When you're ready, push this button, and everything just rolls out to every single node on the cluster is just the experience that we want to deliver to customers, right? And we know that's a big deal because some updates for OpenShift in the past have gone a little less than ideal, and so we know we have to land this correctly. And this is our mechanism of making sure that we are going to get it right.
And so real quick before we move to the next slide, SSH access is something that is more so optional for Red Hat CoreOS. So the only time you should ever actually SSH into a Red Hat CoreOS machine is if something has gone terribly wrong. That is, you need to go in there and debug something, maybe hardware related, or you need to go in there because, like, literally there's some unknown weird thing occurring that just could not be foreseen. Other than that, there's very little reason to actually go on to those machines, and that's by design. If you do SSH into this machine, or these machines, that's okay. Nothing bad is going to happen to you or to your machine here. But what will occur is it will note in the cluster, this machine has been accessed, so it may not be exactly the way that it should be. So in the future, what we're looking at doing is starting to taint these machines after SSH access because, hey, something was wrong, right? So it shouldn't be part of the cluster. You're accessing it. You're looking at something that went wrong. We don't want to destroy the machines, right? But we want to make sure that it's not actually continuing to run with pods in the future if people are accessing them. So we actually already went through that one. Thank you. So we'll hit this. So this is how essentially the updates work. It's a very simplified version, and I'm going to hand wave at the higher level OpenShift stuff. So essentially, at that point, think of what I refer to as the MCO, or the machine config operator. That is an operator running within OpenShift that is in charge of getting its hands on what should be on these hosts, what should be on my workers, what should be on my masters. It ends up providing this document down. Well, it ends up holding this document, I should say, which is called machine config. And this is an ignition configuration file, and this is an OS image URL. Now, ignition configuration is going to be things like dropping files on the system, modifying configuration, adding or removing SSH keys, that kind of thing. The OS image URL is literally a OCI container reference using not a tag, but using a hash so that we know exactly what we're getting to a container that's in a container registry that houses the OS tree content that the machine is supposed to update to. So this is not, we're going to go get some repos and do something, or hey, there's some files sitting on some server somewhere we're going to download. No, this is updates coming through OCI containers to the host itself. So it's basically containers all the way down within OpenShift from this point forward. So the MCD, or the machine config daemon, senses, hey, this machine config that I'm attached to has changed. Can I actually lay down these, can I make these ignition changes that I'm being asked? If the answer is no, it just essentially tells the cluster, I can't do what you're asking, it's impossible for me, get rid of me, reprovision me the way you want, and then continue from there. Generally speaking, the answer is going to be yes. So when the answer is yes, it's going to make those changes to config files, do whatever it needs to do, and then it's going to pass to the pivot, which is a command, which is going to pull down the image that is referenced in the OS image URL, explode that content, pass it to RPM OS tree, which will then make a, basically it'll install the OS kind of side by side with the current running one, so there's no modification to the current operating system. It updates the bootloader, hits the reboot, reboots back into the new system, which is side by side with the old one, so if there's anything wrong, it can go right back to the original one and then report to the cluster, I'm sorry, I couldn't do it, you know, you need to reprovision me. But if everything goes as planned, which it does, it reports back up, I've switched over, I've made the changes that you wanted, I'm in the state that you want. I match that machine config in terms of what I am. So that could be updates to the kubelet, that could be, you know, security updates, that can be all sorts of things. Now the information coming down is what comes down from what we talked about earlier, Cincinnati, which has a graph of all the components and the versions that match each other. And that is essentially gets distributed down to different operators, flows down, comes down through here, and the updates occur from that point. I know it's a simplified, but this is as simple as we can get it done. So another way to look at it, Jeff, you want to do this one?
So over-the-air updates, the way that they work is, as we explained in the last slide, basically we've got a running system here, and we pull down a container out of Quay, and inside of that container, we mount it, and there's no process running inside of it. It's basically just a flat container with some files. We pull in the updates that the operating system needs for the next version, and then we point at that next version and reboot. And simple as that. And we call it the pivot, and it is super, super easy and fast.
So we only have a couple minutes left here before questions. Let's jump through the roadmap that we have quickly. So some things that we want to do that we haven't got to fully yet. So streamlining, which is always happening with every project and product. We want to remove more packages that we know are not absolutely required at this point. The big one that we have is Python and other dynamic languages that have snuck in through other packages. I'm a big Python fan, but we don't want people trying to SSH onto the machines to run Python.
And you can run Python on Red Hat CoreOS in a container.
Yeah, that's what we would rather, if you're going to do that. And of course, continue to shrink these images down. The operating system image, I should say, down.
So we want to get to Fedora CoreOS. We want you guys to be able to use the same technology that we're using in a community-supported version that does what the community wants, right? So Fedora CoreOS is trying to fulfill those roles that other people were using Container Linux for that were not just running Tectonic, right? Some people actually had it as their desktop for a little while. Yep. There were plenty of other use cases like Mesos and
general runtime, yeah, container runtime.
Just a general container runtime, right? And we want to enable that for people in the Fedora space and allow them to help guide some stuff that will then eventually become part of Red Hat CoreOS, right? This is that entry point. And we want to make sure that we form a bridge with the Always Ready OS work that Steph Walter and Don Zickus are working on, because the way that they're gating packages and the way that they're building things is really amazing. And if we get it optimized for the smaller package set of Fedora CoreOS, we think we can really build something bigger from that. Plugin support for Cola, we want to make sure that there are other things that you can do with the testing framework that's part of Mantle. And we want to increase the usability of Ignition. Colin called out that it would be nice if it wasn't URL encoded, so that just editing a couple hand files are going to throw a big configuration problem down the road because it's human readable versus machine readable.
Exactly. Yeah. And the last items we have here, obviously there's more things that we want to do, but essentially we want to continue expanding to other platforms. So bare metal obviously is a really big one, but we also want to expand that CI and OS level testing. So right now we mainly are testing in AWS with some kind of prototype testing in other clouds and other locations, but we want to essentially get that a lot stronger and a lot better. Add more tests to Cola as well. We do a lot of testing with Cola, but there can always be more. And on top of that, we want to port Cola to more clouds. So it does have a limited set of clouds that it tests on. So we do have some work around that as well. So this is just some sources. This is a tiny list of things that we own. We own probably about 7 more pages of these things. But these are some of the ones that we talked about today. And really, do we have any questions? We covered a lot. We didn't go super deep. But yes, sir.
Do you have a release date, a rough release date for the real CoreOS product lines, bare metal supporting release of it?
So the question was, do we have a real release date for bare metal for CoreOS?
Yes, we do have that release day. I'm not sure that we can talk about it at DEF CONF though.
Sorry.
Sorry.
Somewhat at a fancy party in Boston in May.
That sounds like a fancy party. I hope I get to be there.
Other questions? Yes, sir.
For example, you can read an enterprise times you have to have some third-party security scanner that's from the last stone age when it's an SSH access.
Right.
And third-party software companies are not so familiar with containers or not willing to do containers and going that portion. So they don't care if that's immutable your OS underneath if they want to scan it. What would be the best way to provide like an which is access to the machine, so my security department is actually not giving me a hard time when I have a machine that's actually not scanned or not approved in my world. What would be the best way to do it?
That's a really good question. So there's two things that come to mind.
Hold on. So the question is,
sorry, yes.
you've got an ancient security scanner that you need to run on the host, and it uses SSH access for it today. And how would you suggest, or how would we suggest to you the best way to go about doing that? And that's a great question.
Yeah, it is. So first off, I would say with the version that we're pushing out now, they can still do that, and that's okay, right? It's going to show up as an alert that someone accessed these machines. It's not going to stop anything. Obviously, in the future, we want it to be tainted because it's been accessed. But there's a couple things. So number one, it sounds like that sounds like a really good business opportunity to have a security scanner that doesn't rely on SSH or other things like that. However, obviously, that's not totally realistic. So even when we go down the point of tainting these machines, right, and pulling them out from the cluster temporarily, tainting does not mean the machines are unusable at all. It just means that, okay, it's been accessed, it took evasive maneuvers because it's not really supposed to. So the security tool will actually set off a security event. And now to get it back in, you can use, let's say you did it to half your cluster, right? It takes a command to get them untainted and back in the cluster. And in fact, you could do that quickly along with the scanner if you needed to do so. I would guess that, and since this is a future thing, right, so it's not something that we have in there tainting today, but my guess would be too that there would be a way that you could temporarily disable the tainting for a certain amount of time for something like that. But we definitely want to push people towards don't access these. These are only for the cluster. Any SSH should be some sort of a security.
And the other half of that is we need to be very vocal and talking about the fact that we're going to be doing it this way rather than just hiding it in a doc somewhere and hoping that some sysadmin or Kubernetes admin or OpenShift admin doesn't just run into it down the road and can't figure out why no new containers are scheduling to that node. And the taint that we're applying is a no new containers.
Just no new pods, yeah.
No new scheduled containers to it. So the running containers will still be there, and that's even more mysterious to somebody that. So we want to make sure we're very vocal, we talk about it a lot, and it doesn't just come out of nowhere. Which is why it's future work.
Yes, sir.
Is there any reason to expect there might be support for VMware? Or is it something we should just forget about?
No, I
never forget about it.
Yeah, never forget. So we do.
Sorry, we have to repeat the question.
Yes.
We're also running new on the internet. So
Got it.
yes, it's not really.
Got it. So the question was, is there any support or thought for supporting things like VMware? In this case, it's an internal installation of OpenShift, and things like AWS, external clouds is not an option. So we do have on a roadmap, basically our roadmap to continuously be adding new clouds, whether that is external or internal. And I don't know exactly where each one fits down in terms of the roadmap, but I mean, VMware is very popular, right? So I tend to think that it's it's gonna show up, but I don't really know exactly when. Yeah. Sure.
If you talk to a PM,
that would probably
that'll
be
a better answer than we can give.
Yeah. Anybody else? Okay. Thank you.